Now we want to study the algebraic proof for ds in the polar coordinates. What is this ds? The delta is what we this meaning ds with the diagram I'm going to represent. See, in a polar curve, we are going to choose a point P here. Whenever P point moves just in the adjacent to the Q, what is the we want to this arc length I want to find out using these data that is called ds. Why this is very required? This is very required while calculating the I can say that curvature and all those things. This is arc length. Sorry, the length of the I can say that this is the curve I want to find out. How to find out this one in a polar form? But in Cartesian form, very easy. Whenever p is there, x comma y, and q is there, x plus delta x, y comma y plus delta y. I can say that the Pythagoras, whenever this act as a, I can say that hypotenuse, and ds is equal to square root of dx square plus dy square, you can easily find out. But it is here how to find out. That is our basic idea. How to find out this ds, a minute change in the arc length from p to the q. How to find out in polar form? Let us find out in Cartesian. If the given point is like this and another point like this, we know that ds is equal to square root of dx square plus dy square. Square root of here this thing I know in xy plane using the standard Cartesian length formula. In the xy plane already we know that ds can be calculated as I told you. Ds square is equal to dx square plus dy square. But let us convert this into polar form by using this formula. That is enough to prove this. What is the value of ds here? Now, as I told you, x is equal to r cos theta. Whenever the point is given, we can r theta, every polar coordinate can be written in the Cartesian coordinate x comma y with the standard using formula x is equal to r cos theta and 2 y is equal to r sin theta. Now what happens? We are going to find out the differential dx and dy. Uh, we are moving along the curve, both are changes. We need to differentiate what happens x and y with the I can say that product tool, because in order to find out dx, they given we can say that dx by d theta is equal to, can use the product tool. Where the question comes, where that d theta bends here, they will be going to cancel. Why use dx and dy instead of dx by d theta? We may ask that they are connected from the step to take the derivative. Dx by d theta is equal to like this, and multiplying entire equation by d theta, the d theta are going to get cancelled. I can say that cancel here. Then I can say that, see here, dx by d theta is equal to dr by d theta into cos theta minus r sin theta. Whenever multiply entire equation by d theta, this is equation dx d theta cancel here, and dr by it only remains dr into cos theta minus r sin theta into d theta are going to happen. This is how we can find out dx, and similarly we can find out dy here. Now already we know that ds square is equal to I can say that dx square plus dy square. This I means I can say that square the dx and dy. We need to find, we know the dx but we don't know dx square. Just to square it and we can get cos square. We can use I can say that a minus b whole square formula. You can write dx square is equal to cos square theta dr square theta minus 2r sin theta into cos theta into dr d theta um, plus r square sin square theta into d theta square. That is what we can just, by using a minus b whole square, we can do it like this. Similarly, we can find out dy square is equal to sin square theta into dr square plus 2r sin theta cos theta into dr d theta plus r square cos r square into cos square theta into d theta square. Now, if you add it, you can get the one term will going to get cancelled here. This term and this term will get cancelled here. Minus 2 r sine theta into cos theta dr d theta will going to get cancelled. They have identical but they have opposite sign. They will going to cancel. The remaining thing is this is one ds square is equal to uh, if you here and you can take a dr square common. This is cos square theta plus sin square theta, and here you can take r square d theta square common. This is becomes remaining sin square theta plus cos square theta. Using the fundamental trigonometry identity, sin square theta plus cos square theta is equal to 1. Finally, we can get ds square is equal to dr square plus r square d theta, and ds finally we can go to square root of dr square plus r square into d theta square. This is how we can, whenever the we can find out what we are going to, ds is what it represents this length, just by converting the, we already know this is the delta x, and this is if, means if r theta is there, the corresponding I can say that um, coordinate in the Cartesian plane, that is x and y, corresponding the Cartesian plane x plus delta x, y plus delta x. The corresponding ds is square root of dx square plus dy square. Just converting the Cartesian into polar form, or sorry, s um, polar form, you can easily represent this delta ds. Okay, this is how we can. This is very important in further classes, but only to remember. Well, differentiating it dx by d theta, you are using dx here. What is dx is? Dx is a written as simply dx or d theta, represent completely different, incredibly tiny and almost zero change in the value itself. Whenever they given dx, if suppose dx by d theta is equal to its derivative, then differential is like this: dx is equal to derivative into d theta. That is what differential. That that concept is used in finding out the ds here. Thank you very much.